You feel it the moment you wake up. Not grogginess. Not the slow crawl toward awareness. You open your eyes and your mind is already running at full speed. Faster than it has ever run before. You know the weather, your schedule, the 3 most important things you need to do today, and the name of that song you could never remember. You know them all at once, the way you know your own name. What changed last night wasn't sleep. It was surgery. A chip smaller than a grain of rice is now sitting in your prefrontal cortex. And the world you woke up into will never be the same. This is not science fiction. This is the real scientific trajectory of a technology already under construction. The question researchers, ethicists, and neuroscientists are now asking is not if brain-computer interfaces will reach mass adoption. The question is what happens to you, to your identity, your freedom, and your sense of self when they do. Right now, most people think about AI as something external. A phone, a screen, a voice assistant in a small speaker on your kitchen counter. You interact with it and then you put it down. There is a gap, a physical, psychological gap between you and the machine. That gap is what makes you feel like you are still in control. The technology being developed in laboratories right now is designed to close that gap forever. Elon Musk's company Neuralink has already implanted its first device into a human subject. The patient, Noland Arbaugh, had been paralyzed from the shoulders down since a diving accident. After the implant, he could move a cursor on a screen using only his thoughts. He could play chess. He could browse the internet. He did this lying in a hospital bed with a device no bigger than a large coin sitting in his skull, communicating wirelessly with a computer nearby. The interface between his mind and the machine worked, and he described the experience not as mechanical or alien, but as natural, as if his thoughts had simply found a new way to reach the world. Neuralink is not alone. BrainGate, a consortium of researchers from Brown University, Massachusetts General Hospital, Stanford, and others, has been developing similar devices for over 2 decades. Their implants have already allowed paralyzed patients to type, control robotic arms, and communicate at speeds that were previously impossible for people with their conditions. The science is not theoretical. The science is happening. The question is only about scale. What happens when this technology is no longer reserved for medical patients? What happens when a neural implant becomes something you can choose, the way you choose a smartphone or a fitness tracker? Think about what changes first. The most immediate transformation is memory. Right now, your brain is a biological machine. It stores information imperfectly, emotionally, and selectively. You remember the embarrassing thing you said at a party 7 years ago with perfect clarity. You forget the name of your new colleague within 30 seconds of meeting them. Your memory is shaped by emotion, repetition, sleep quality, and chance. It is not a filing system. It is more like a living organism, constantly reorganizing, decaying, misremembering. Now imagine a backup, not a metaphor. A literal, digital backup of your memories, searchable and retrievable the way you search your email. MIT neuroscientist Ed Boyden, who co-invented the technique of optogenetics, a method of using light to control brain cells, has spoken extensively about the future of neural recording technology. The direction the field is moving points toward devices that can read and eventually write to specific clusters of neurons. The implication, at sufficient resolution, is that memory itself becomes editable. You remember your first day of school. But what if you could also remember it from your mother's perspective, recorded through her implant and shared with yours? What if you could search your own past the way you search a document, typing keywords and pulling up exact moments? What if you could choose to forget? The technology does not stop at memory. Cognitive speed is next. Your biological brain processes information through electrochemical signals. Neurons fire across synapses at speeds measured in milliseconds. This is fast for a biological system. It is slow compared to silicon. A neural implant with sufficient bandwidth could not simply store memories. It could accelerate the speed at which your brain processes information, draws connections, and generates solutions. Could, in effect, make you smarter. Not in the way caffeine makes you feel sharper. Smarter in the way that adding a second processor to a computer makes it faster. A measurable, permanent cognitive upgrade. Ray Kurzweil, the inventor and futurist who serves as a director of engineering at Google, has predicted for decades that the 2030s will see the first practical merger between human intelligence and artificial intelligence at the neurological level. His timeline has been criticized and revised, but the core thesis that biological and digital cognition will eventually merge is no longer considered fringe. It is the working assumption of entire research departments at institutions including DARPA, the Defense Advanced Research Projects Agency, which has spent hundreds of millions of dollars developing brain-computer interface technology through its neural engineering system design program. Now stop and ask yourself one question. If the implant makes you smarter, faster, and better at everything, how do you know that the thoughts you are having are still yours? This is not a philosophical trick. This is the central problem that neuroscientists and ethicists are already wrestling with. When a device inside your brain is filtering information before it reaches your conscious awareness, when it is suggesting answers before you have finished forming questions, when it is shaping which memories feel significant and which feel forgettable, at what point does the line between your intelligence and the machine's intelligence disappear? Philosopher Andy Clark at the University of Edinburgh has spent his career studying what he calls the extended mind, the idea that the boundary of the self is not the skull. Humans have always used tools to extend cognition. Writing externalizes memory. Calculators externalize arithmetic. Smartphones externalize navigation and social contact. Clark argues that a brain implant is simply the next step in a process that has been ongoing since the first humans scratched symbols into stone. Your mind, he would say, has never been entirely inside your head. But there is a difference between a notebook and a chip that cannot be removed without surgery. There is a difference between searching Google and having Google search you. Consider the social consequences. Access to this technology in the early years will not be equal. Neuralink's first clinical procedures cost hundreds of thousands of dollars. The implants require neurosurgeons, sterile operating environments, postoperative care, ongoing software support. In a world where a cognitive implant gives its user a measurable advantage in every professional context, faster recall, superior pattern recognition, accelerated learning, access to that implant becomes access to opportunity itself. The company you work for may one day require it. Not through law, through quiet pressure. Through the simple fact that the colleague who accepted the upgrade processed the quarterly report in 4 minutes while you spent 4 hours. No one will tell you that you must install AI into your brain. But the unspoken alternative will become increasingly clear. This is not a distant hypothetical. It mirrors the pressure that already exists around smartphones. In the 1990s, not having email was unusual. By 2005, not having a mobile phone was an inconvenience. Today, not having a smartphone makes you functionally invisible in most professional and social environments. Neural implants will follow the same adoption curve, beginning as a medical miracle, transitioning through luxury, arriving finally at quiet social necessity. And then comes the question that no one in the field has yet answered satisfactorily. Who controls the software? Your phone runs software written by a company. That company can update it, push new features, remove old ones, and in extreme cases, deactivate it remotely. When the software is inside your brain, the same architecture applies. Firmware updates that change how you process emotion. Patches that alter the weight your mind assigns to certain memories. And behind all of it, terms and conditions you almost certainly will not read, governing what the company can do with the data your mind generates 24 hours a day. Demis Hassabis, the co-founder of Google DeepMind and one of the most respected figures in AI research, has consistently warned that the governance of AI systems must advance in parallel with the technology itself. His concern, shared by the researchers at the Center for Human-Compatible Artificial Intelligence at Berkeley, is that systems optimized for efficiency may not be optimized for human flourishing. A neural implant designed to make you more productive is not the same thing as a neural implant designed to make you more free. The most counterintuitive truth about this technology is not the danger. It is the desire. The studies on early Neuralink patients consistently report the same thing. The experience does not feel foreign. It feels like a natural extension of the self. People who have used brain-computer interfaces to restore lost function describe a sensation not of operating a machine, but of simply willing something to happen, and having it happen. The brain adapts. It integrates the interface. It treats the signal as its own. That seamlessness is the most powerful force behind mass adoption. And it is the reason that once this technology becomes widely available, its spread will be faster than almost anyone currently predicts. You are living in the last era when the boundary between you and the machine is still clear. Right now, you have a thought and you reach for your phone. There is a gap, a small one, a moment of intention, then action, then result. That gap is, in a very real sense, your freedom. What happens when it closes is not a horror story. It is not a utopia. It is a transformation so fundamental that the questions humans will ask about identity, consciousness, privacy, and equality in the world that follows will make the debates of today look like the first rough sketches of a map for a continent no one has yet explored. You woke up this morning with a mind entirely your own. The next generation may not be able to say the same thing. And they may not, for even one moment, think of that as a loss.